Hello, everyone. My name is Klea Dhimitri, and today I'm going to talk about how Hamamatsu fits in the quantum technology space. So if you're not familiar with Hamamatsu, we're a worldwide organization headquartered in Hamamatsu, Japan, and we've been making photonic solutions and components for around 70 years. And here is a breakdown of our sales by application. So really our bread and butter is medical instruments. So think PET machines, CT machines. Our second biggest market is industrial instruments. Think semiconductor, non-destructive testing. For about 10%, we have an analytical instruments. Think gas detection, methane detection, and water inspection. And then we have this others category that is comprised of smaller applications, as well as where our emerging technologies sit, such as LiDAR and quantum. And today we'll talk about our products and our place in the quantum technology space. In addition to providing components for industrial equipment, we've also been known to participate in very big scientific efforts. And I think this can be really well seen in high energy physics. We have delivered tens of thousands of detectors for experiments such as the Kamiokande experiment and CERN. And really what these efforts taught us is that building big and challenging ideas demand very high performance devices as well as reliable hardware. So it's always great to make a photonic device or solution, but it's very also important to make sure you maintain that precision and accuracy as you scale up to tens or thousands of them. And we think these are lessons that we can apply to the quantum technology space. In addition, I've just gotten some quotes here from members of higher management at Hamamatsu from a company report. And really the big takeaway here is they see a lot of potential and growth for us in this space. So let's just jump right in. So the first area is quantum computers and simulation. And so you may have heard of qubit modalities like trapped ions, neutral atoms, and nitrogen vacancies. And they're typically racks of photonic hardware for light generation, beam steering, and detection and associated electronics. Now, of course, photonic qubits use photons, but they're a little bit different because they typically integrate a chip architecture. But again, the reason they have photonics in their toolbox is it's very important to apply things such as gate operations and detecting qubit states. So where does Hamamatsu play a role? Well, we really play a role in modulation and detection. So for modulators, we provide an LCOS SLM, and this is really great in confining atoms in a static array, and you can do this via optical tweezers, and you typically see this in neutral atoms. And for qubit state detection, we have a wide range of photonic solutions, detecting the fluorescence or lack thereof to tell you if your qubit is in a 0 or a 1. And some of our outlook for qubit state detection is we're working on trying to develop our SPAD arrays, as well as really work on some low latency readout for our cameras. And jumping into the next area of quantum communication and networking. So again, here the photon acts as a secure carrier of information, especially if you're going to transmit it over long distances. Similar to computers, you really typically have racks of photonic hardwares, at certain nodes or end users, and they typically include things such as single photon detectors. So again, we offer some single photon detectors in the NIR with different form factors, but future outlook for us is we're really trying to work on some high detection efficiency detectors in the telecom region. The last area I'll talk about is quantum metrology and sensing. Again, quantum sensors could be used to probe environments for very accurate measurements of electric fields, magnetic fields, gravitational fields, and timing. And so typically a quantum sensor will have some lasers, some optics, the qubit modality, and a detector. And again, when that quantum sensor is in that environment, that information of that measurement can be communicated through photonic emission, such as fluorescence. So again, we provide a wide range of photonic solutions, to detect that higher light level, as well as that single photon level. In addition, I was talking about some products that Hamamatsu makes, but we also have capabilities that we think could be useful for the quantum 2.0 space, especially for products that we may not have right now. So we are experts in glass processing, semiconductor processing, really systems design. How do we combine that hardware, firmware, and software? And our laser promotion division typically integrates optics with some laser technology for products, in testing and equipment and manufacturing. And really our goal here is to provide key tools and equipment to help emerging quantum applications progress at every step of the way. And this includes both industry and academic research. And lastly, feel free to contact us, myself or my colleague, Taka Otake. And thank you very much.